Hello everyone, my name is Abul Qasem Sadeghi Niaraki from Department of Computer Science and Engineering, as well as I am member of XR Metaverse Research Center, Sejong University. In the lecture 5 of Artificial Intelligence and Big Data, we will delve into fascinating journey of AI algorithm focusing on their evolution. This is part of section 3, you may remember, evolution of intelligent decision making in AI and big data course, where we'll explore how AI as a field has advanced from traditional algorithm to more complex and adaptive systems. The core topics we will cover today, including the evolution of AI algorithm, as you see in the screen, evolution of AI algorithms. We will try to find differences between traditional and AI-based algorithm and their real-world application. Additionally, we will discuss key historical figures and moments have shaped AI's development. After introduction, as you see in the agenda, in the lecture 5, I'll focus on the evolution of AI. Evolution of AI is part of evolution of intelligent decision making. Specifically, we will try to focus how algorithms have transferred from traditional rule-based approach to more advanced AI algorithm. So we will try go from here to the AI algorithm. We will then cover foundation of AI, which include philosophical, mathematical, cognitive influences leading to development of modern AI system. The lecture will also explore the relation between AI and human intelligence, comparing AI's capability with the human cognitives, cognitive functions such as reasoning, learning, decision making. After that, I'll dive to different types of AI, including AI narrow intelligence, AI general intelligence, and hypothetical artificial super intelligence. We will touch those sort of, AI types. Then we will then dive into various AI approach, such as acting, thinking, humanly or rationally, as well as specific AI approaches, like as problem solving, knowledge representation, learning, and decision making. So as you can see, we will touch to the AI branch, and this AI branch consider with the AI history. Another point we will touch, you may remember from the first lecture, second lecture, right? First lecture was introduction about the syllabus. Second lecture, we will dive into DIKW, and we will find problem enriched DIKW model and AI branches. We will illustrate how AI system process data through the various stages, from raw data to optimized decision making. Finally, at the end of these lectures, maybe this lecture and another week lecture, finally we'll provide an overview of AI history, tracing the development of AI from its early symbolic reasoning roots to modern achievements, without focusing on specific milestones such as neural network and machine learning. This structured approach will help clarify how AI has evolved in both theory and practice. Before I dive inside lecture 5, let's recap of lecture 2, 3, 4 quickly. You may remember in the lecture 2, because always we need to review, as I mentioned many times. If you don't do review, you will forget soon. In the lecture 2, we already dived into world transformation modeling. We try to talk about the physical world and cyber world, like what is the cyber world, what is the physical world, the bridge between physical and cyber world, and then we try to talk about why transformation problem to the cyber world. So computational power, precision, and efficiency. And we try to talk about the program, including data structure. Nicholas Rich, the foundation of the Pascal programming, introducing data is algorithm. Data structure information represent real world algorithm procedure to process data. Then we try to also talk about the philosophical perspectives, talk about the Plato beliefs, physical, about the abstract world and mental world, and about the Baudrillard's simulation, blur reality, like social media, importance of social media sometimes make us, we think that social media is a reality. So Castell also talk about digital and physical world are interconnected. So the merging physical world drives innovation, data and algorithm is a fuel of AI and big data. This is and future solution rely on digital tools. So that's why this class is important. To solve finally what? Finally, we want to solve the real world problem. This is whole lecture 2 within 1 minute. Now, if you need more, please review and see 3 hours video more talking about this lecture. Let's recap lecture 3. So in the lecture 3, we talk about the program enriched DIK pyramid, and we talk about that this program enriched pyramid, which is traditional data, information, knowledge, wisdom and optimization. And then we try to in that pyramid we said from data part, here is the data, here is the algorithm, these 4, right? Make a connection between this formula and pyramid. We call it program enriched DIKW pyramid. So example, like data collect the sensor, information process data of the object like pedestrian and traffic light, knowledge, apply traffic rules and road condition to interpret situation. Wisdom, decide to stop or slow down based on the situation, and optimization is the insurance of the efficient navigation. So we talk about in lecture 3, we talk about many about this pyramid. So if you want, you can check more about from the long video about this concept. So in lecture 4, what we try to cover about the data handling practice. Then we went through the historical progress of the data. What happened from 90 to 1960, from early recorded punch card, and then go to the computer, electronic computer from 1950 to 1970, then database and personal computer, internet, and then big data era, and then AI assistant data preparation. This was history. Then we tried to cover the characteristic of big data. We started about the 3V to 4V, 5V, 6V to 9V. And that is the characteristic of the big data. Talk about some application and future trend we cover through the lecture 4. For more information, you can refer to those lecture. And we now going to touch, lecture 5, which is part of AI and big data courses. So you may remember whole course, because course name is the AI and big data. We will consider the evolution of AI and big data. So you may remember that we defined the several sections. Section 1, 2, foundation of data and knowledge, evolution of data handling. Here, for today, we will go to section 3. We start section 3. For today or maybe next week, we will cover the evolution of the AI and how from the traditional algorithm start and to reach to the AI. And later on, in the few weeks later, we will talk about more data-driven decision making. So this is the just I want to make everything clear for you to remember what we are. So if I recap program enrich DIKW model, as you can see here, that in lecture 1 and lecture 2, we mainly focus about the data. You see section 1 and section 2 is a data. So, and section 2, 3 is algorithm. So easily, I made very nice graph to show that section 1 and section 2, those video focus about the data. As you see, everything is the data driven. Finally, we will come to the data driven decision making. So data is important. So too many discussion about the data and big data. And in the section 3, we will cover this part from the traditional AI, traditional algorithm to the new algorithm, which is based on the AI. And old algorithm is explicit, means everything clear. You should clearly, a human should clearly say to computer what I want. But in the AI algorithm is implicit, means hidden. So you don't talk. Calculation by computer will be automatically done. So computer should silently knows many things of you and learn. And learning from old, how to learn, technique to learn is increased. So this is the start for section 3. We will dive into first part of the section 3, evolution of intelligent decision making. So as I mentioned, we will go through the AI algorithm, which is evolution of AI. We already come to this point, and this evolution of AI, we will discuss many parts in here, as I mentioned. Let's start with the traditional, algorithm, vice versa, AI-based algorithm. This is, I try to bring your mind to the point which is track of continue our lecture. So that's why I try to review the previous one within few minutes and come back to the track of the AI. To know about the AI, we need to go to the history, see the traditional, algorithm. What is the algorithm? Let's dive into core concept of the algorithm, which is fundamental not just to computer science, but also to many other fields. As shown on this slide, an algorithm is a precise step-by-step procedure or set of rules for solving a problem or accomplishing a specific task. Now, this may sound very technical, but let's break it into something more relatable. Think about a receipt for banking, issue when you go there for request something to buy, or in the context of computer science, algorithm are building block. All computer building block means fundamental part of the algorithm. So they are used for everything from searching for a contact in your phone address or complex data analyzing used in AI system. So it is safe to say without algorithm we won't have a modern software or complex functionalities that computer offer today. Let me give you for example, when we want to cook for example, want a cake, a recipe, before we make a cake, recipe provide a structured approach to combining ingredients and baking them at the right temperature. If you follow the steps exactly, you'll get the same result every time. A delicious cake. This is clear for sure. This is the essentially how algorithms work in a computing tool. So this is the what we consider algorithm. They provided a structured, repeatable approach to problem solving. This is the meaning of algorithm. So as you can see, a cooking recipe we can consider as a algorithm. Let me ask you one question. What is the meaning of algorithm? What is the root of the algorithm? What is the etymology of the algorithm meaning? algorithm come from where? Can you tell me? Please pause the video and explain to me what is the algorithm, this word, algorithm. So, can you tell me about the history? Please pause and tell me. Okay, after thinking, let I explain to you. You know, the algorithm, Persian origin of the algorithm. This is come from Persian word. In this slide, we explore the fascinating etymology and historical background of the word algorithm, a term that is central to the field of computer science today. As shown, the word algorithm is derived from the name of the Persian mathematician, astronomer, and geographer. Name was Muhammad ibn Musa al-Khwarizmi. Al-Khwarizmi is the last part of his name, Al-Khwarizmi. This is meaning of some places. Because Al-Khwarizm is a city was historically a major cultural and scientific center, once part of Greater Persia. Today, it is legacy remain in cities like Khiva in Uzbekistan and region of Turkmenistan through the Khwarazm. Khwarazm is the city name long time ago. No longer exists as a single city now. And, Al-Khwarizmi is a family, but is a place name, this city name. For instance, if you see my name, for instance here, like Niaraki, this both Sadeghi Niaraki is my family name, but this is some adjective explaining. For example, Sadeghi means who is telling true always. And Niarak is referred the place. There is a place in Iran, is a Niarak, which is I return to the referring to the family Niaraki. So same thing here. Al-Khwarizmi, I is referred to family, but Khwarazm is the city name. So as you can see, he lived in 9th century. His work has had a profound impact on the mathematics, particularly in the field of algebra and algorithmic problem solving. So this is his great task. Persian and Persia, Persian refer to somebody from Persia. Persia historically associated with the country of Iran. So what even more interesting in how meaning of term evolved over time in the medieval Latin word algorithmus was used to describe the decimal number system, which Al-Khwarizmi has helped popularize through his mathematical work. On the 7th century, this transfer to the algorithm in the French. And finally by the late 19th century, algorithm has taken on the meaning we use today, a set of rules and steps for solving a problem. Al-Khwarizmi, that scholars, that researcher contributes go beyond just terminology. Al-Khwarizmi is not famous only for his name is referred to the algorithm. He wrote, book name is Compedius, book on calculation by complexion and balancing, which introduced systematic method for solving linear and quadratic equation. His work essentially laid on groundwork for the modern algebra. So algebra course also come from him. So in many ways, he is not only father of the algorithms, but also he is a father of the algebra. Wow. He is also father of algebra. Yeah, this great man. So we are proud of him. So he is also father algebra, a title he is often, credited with. Think about this for a moment, everybody. Every time we wrote an algorithm in programming, we are in some sense continuing a legacy that started over 1,000 years ago. The structure methods we use today to solve computational problems have their root in the Al-Khwarizmi work. His method influenced European mathematicians, shaped development of the computer science, and we know it today. So then next time when you hear the word algorithm, remember that it's not just a technical name. It carries with its rich history of mathematical discovery that connect different culture and eras. So this is the very important point. You should try to think about it. And for your information, in this slide, shortly I put some figure to explore the expansive Persian Empire and its influence over vast territories. As shown on the map, Persia historically including all or parts of the 26 modern days country. This range, from Iran, Afghanistan. Iran, if I roughly draw the current Iran, I don't know roughly, maybe like this. Yeah, this is the current Iran, Persia, center of Persia. Including, but this border is the Persian Empire time, including 26 country. As you see, like full country covered, like Iran, Afghanistan, Pakistan, Tajikistan, Turkmenistan, Uzbekistan, Armenian, Georgia, Turkey, Iraq, Lebanon, Palestine, Israel, Syria, Jordan, Kuwait, Bahrain, and part of Uzbekistan, India, part of Saudi Arabia, part of UAE, Qatar, Egypt, and here is the Egypt until Greece, until here start current Europe, including Turkey, everything. So this is just for your information when we talk about the Persia, but now is many country included. So that Al-Khwarizmi belong to this 20, we cannot say only Iran. Every country this value person belong to, because many country is covered by Persian Empire time. Okay, let's go, after knowing about root of the algorithm, let's see the key component of the traditional algorithm. This slide breaks down the fundamental component of the traditional algorithm. As you can see, the algorithm must have clear input, yes, and clear output, and should be infinitive. So and should be effective and definitive. So let's explore some of them and see these characteristics in more detail to understand why they are so crucial in creating reliable algorithm. So input should be clear, input should be result procedure after executing algorithm. And the important thing, definedness. Each step of algorithm, please pay attention. Each step must be clearly defined when we talk about the algorithm. There should be no ambiguity. For example, compare first two number. This is, definitive step. However, sometimes vague statement. For example, when we say compare first two number, this is algorithm. Compare the first two number. It is very clear. But when we say, for example, so compare first two number, but when we say make the number better, doesn't work because it leaves root of interpretation. Definedness is a key reason why algorithms are so reliable, because every step is unambiguous. The same algorithm cannot be executed in any country, anywhere in the world, in any country, if not clear. So it will be if definiteness, then that produce same result. So when we talk about the finitiveness, we talk about the algorithm must be determined after a finite number of steps. It cannot run, indefinitely. For example, a well-designed search algorithm will stop when the item is found or after checking all possible locations. This property is particularly important in the practical application where the computational resources like time and memory are limited. An algorithm that doesn't terminate could end up consuming too many resources. So this is not good, right? Crashing a system or leaving it unusable. So finitiveness is very important. Effectiveness, each step of algorithm must be basic enough that it can executed by a human or machine. Complex steps should be break down into simpler instructions. For instance, when we say add two number, is it an effective step? While we said solve this complex, equation, may need further breakdown into more manageable task, right? So anyway, effectiveness ensure that the algorithm can be implemented in the real world system. Why? Because we have, you may remember, we have a many world, real world, printed to cyber world. When we do a great algorithm, then we need to implement in the real world. So this is very important. So also some additional characteristic algorithm should be correctness, should be use computational resource like time and memory efficiently. Generality should be general. A good algorithm not only work for one specific case, but should be applicable to a class of problem. This generality means algorithm can handle various input within its intended domain. So let me, for example, for generality, I give one example which is not included this slide. Consider a search algorithm, right? Search algorithm that can, work not just for finding a name in a contact list, not just for searching name, right? But also we can use the search algorithm for locating files on their hard drive or identifying path in the graph. So 3 application of same algorithm, generality. This makes algorithm much more general and useful across multiple applications. And another modality, when we say modality, refer to practice of breaking down complex algorithm into the smaller manageable sub-algorithm or function. This makes the algorithm easier to understand, implement, and maintain. Modality is really essential for both scalability and maintenance. For instance, if you are developing a large software system, modular algorithm allow you to isolate and update a specific component without affecting the entire system. This reduces the chance of introducing bug and makes debugging easier. Wow, modularity is very good. Okay, now is enough for algorithm. Let's touch AI. AI refer to system designed to perform tasks that typically, require human intelligence. This is the very important. So tasks require human intelligence. So AI, if I draw, please pay attention. I am teaching very professionally and very simple but very deep. Any student from any department can understand. You remember we were talking about the physical world and we bring problem to the cyber world, and as Plato mentioned, we have a mental world. So mental world is the human, right? Human intelligence. When we try to add and design to perform tasks that typically need the human intelligence, add to that model which we created, algorithm which we created based on the physical world, add the mental world to human intelligence, then we call it, that is some sort of algorithm, we call it AI. Wow, very nice. These tasks including learning, reasoning, problem solving, perception, language understanding, because humans do all of them. AI essentially simulates human cognitive process in the machine. So let me breaking down AI. 2 parts. AI, artificial, A, and intelligence. Artificial is something created by human and not occurring naturally. So artificial created by human come from mental world. Intelligence, the ability to acquire and apply knowledge and skill. So you apply to inquire or set the knowledge and skill. So intelligence. This is the intelligent artificial. This is a key point because it remains us that AI system, while highly advanced and still human creation. They are designed by use to handle tasks that normally require human thought process but are done faster and often more accurately by machine. Regarding the capability of AI, if I talk about the capability of AI, I could say AI analyze vast amount of data, recognize complex pattern, make prediction based on the previous data, make decision in even unclear and uncertain or sudden environment, fit to the new conditions. For instance, AI can process large data set in a second. How? For example, you have a 100-page document which is in Korean. If you give to the translation, within few seconds, all translated to English. Can human do? No. Within 1 second, can you translate 100 page even if you are native Korean speaker? Something, that would take human years to complete for some time for some application. For analyzing medical records to predict the financial market trends, AI uses its ability to detect pattern and make sense of unstructured data to solve complex problems. So let me give you one example, like a real-world example for self-driving car. Inside when we designed the self-driving car. Great example of AI in action is a self-driving cars. These days is very popular example. This vehicle interpret their surrounding using the sensor and camera. AI system in a car make real-time decision about the navigation, speed, safety. AI is capable of driving autonomously by integrating all this information and making decisions based on the real data. So think about how complex this is. Car has to process many information such as pedestrian, road sign and other vehicle and decide how to navigate safely. All be done by AI. So AI enables car to think and make decisions similar human driver but with more precision and speed. Because we bring the mental to here. Okay, let's go. We don't have much time. So algorithm, as I mentioned, step-by-step procedure, but in the AI we bring the human intelligence. So let's give some characteristic of the traditional AI and some characteristic of the current algorithm. So traditional algorithm and current algorithm, which is AI algorithm. So in this slide, let's talk about the algorithm characteristic. Problem scope. Traditional algorithms are designed to solve a specific, well-defined problem. They excel when the problem is narrow in scope, such as sorting a list or finding the shortest path in graph. Right? Then design process. Traditional algorithms are human crafted. We call it human crafted, meaning programming explicitly, please remember, explicitly means openly, clearly, not hidden. Explicitly design and implement each step of algorithm. Every step is manually coded and predefined. Require a deep understanding of problem domain. So this human intervention is both a strength and limitation when human crafted, right? On one hand, programmer has full control over algorithm logic. This is good. But on the other hand, these algorithms cannot learn or adapt their own. This is the problem when human. This requires update and revision when the new. So that's why I will talk later. This has some advantages, disadvantages. The advantages recently come. Many recent is the hybrid AI. We will talk. Hybrid AI means we combine a traditional AI because sometimes traditional AI has. You cannot say traditional AI doesn't have any advantages. Please attention. So adaptability. So it has a limited adaptability. They cannot just a new data or change in their environment without manual reprogramming or modification. So you cannot change suddenly data. Otherwise, you need to manually tell. So this is the if you add a new type of input in the traditional data, you need rewrite the code. Technically, if I talk, AI-based algorithm, on the other hand, can learn from new data, and you don't need the reprogram and adapt without much human intervention. So predictability and pattern recognition. So algorithm highly predictable. So given the same input, they will give you produce same output. They make them consistent and reliable. However, they lack of ability to recognize complex pattern in the data because they rely on predefined algorithm. And then lastly, data handling. Data handling, typically work with a small structured data. They require clearly defined input and not built to handle vast amount of the unstructured data. So, as you can see, let me give you more characteristic of a traditional algorithm. Inter means between. Predictability means that the traditional algorithms are transparent and interpretable. So interpretability means ability means can means transparent. This means the decision-making process of this algorithm is easy to follow, and each step is traceable. This transparency makes it is much easier to understand why and how particular results are achieved. This is very helpful for debugging. And another is the handling complexity. So usually traditional algorithms struggle with high complexity. They are not well suited to handle high complexity. And generalization. Traditional has a limited generalization. They are typically designed for a specific scenario, meaning they work well only within a domain they are explicitly crafted for. Extending these algorithms to new unseen problems often requires significant redesign or adaptation. And another computation needs. Traditional tend to have a lower computational requirement compared to the AI. So computation requirement is lower. And the last characteristic of traditional, which is limited of that they are required manual update for improvement. So this is the problem. Unlike AI-based algorithms, which are automatically improve themselves through the training with the new data, traditional algorithm must be manually modified to enhance their performance or to adjust the new conditions. This is the characteristic of AI. I think it is enough. We are going you have a rest and continue the AI characteristic in this is the video part 1 of lecture 5. Then we will continue for part 2 about the AI characteristic. Thank you.